Introduction, Ari. This is joint work with Juraj Somorowski, Jörg Schwenk, Markus Kampmann and Maiko Jensen from Horst Görz Institute for IT Security at Ruhr-Universität Bochum. My name is Andreas Meyer, and the title of this talk is On Breaking SAML, Be Whoever You Want to Be. Our research was recently published on this year's Usenik Security Symposium at Bellevue, Washington, USA. So at first I'd like to give you a short overview of the talk. I will present some novel attacks on the SAML protocol which allowed us to authenticate as whoever we wanted to be. We did the first in-depth analysis of 14 prominent SAML frameworks and providers, and about 80% of them could be broken by novel XML signature wrapping attacks. Possibly millions of users were affected by our findings and thousands of SAML-based websites. So, first, the motivation. Who has ever heard of SAML before? Oh, okay, cool. So, SAML is the abbreviation of Security Assertion Markup Language and is an XML-based protocol for exchanging authentication and authorization statements. And these claims are stored in so-called assertions. And we have typically two use cases in SAML. First, the browser-based single sign-on, and second, with web services. So, where is SAML used? SAML is very widespread, and as you can see on the top left, it is used by Google Apps and also on Microsoft Office 365. And the new eID cards, like the German Neue Personalausweis or the Swiss counterpart Swiss ID, also facilitate SAML. Also, the most leading cloud-based customer relationship provider, Salesforce, uses SAML, and additionally Amazon to secure his web services for EC2. So first, I'd like to explain how browser-based single sign-on with SAML works. We have four actors. First, the user, which navigates a user agent, which is normally a browser. Then we have an identity provider, which authenticates the user and issues the so-called SAML assertions. And we have, last but not least, a service provider, which provides or offers a service or a restricted resource. So, first, the user navigates his user agent to a protected resource on the service provider. The service provider then issues an assertion request and sends this request back to the user agent, and then it gets automatically forwarded to the identity provider. The identity provider then authenticates the user by any means and issues an SAML assertion, which is additionally signed by an XML signature. In our example, the issued assertion is for user Bob with the role guest. And this assertion then gets sent back to the user agent, and the user agent automatically forwards the assertion to the service provider. And then the service provider first validates the signature in the assertion and then evaluates the content of the assertion. And third, the user gets authorized. And it's important to emphasize that all communication between service provider and user agent and identity provider is secured by SSL and TLS channels. Additionally, the assertion is secured by an XML signature, as said before. So, we could assume that SAML is pretty secure. I will show you in a few slides that this is not true in some cases. So, back to the SAML assertion. Here you see an example of a SAML assertion, and this assertion tells the following story. It was issued by the secure IDP service provider and authenticates the user Bob at secureidp.com. The assertion is exactly 5 minutes valid, as indicated in the conditions element, and it is for the secure SP service provider. For the sake of clarity, I will now switch to the XML tree-based notation, as you see on the right side. Okay, So how is an assertion or a SAML response message secured by an XML signature? The XML signature is here with the green elements, and the reference element with the URI attribute 123 points to the secured content. And as XML signature is an indirect signature, the signed info element with the reference and the digest value of the signed content is secured by the signature. Okay. So I will now explain how a service provider processes such a SAML response message normally or typically. So first the assertion is sent to the service provider, and in the first part the signature is verified. And this verification is ID based, which means the service provider looks after the URI attribute and searches this element in the XML tree and then knows which content is secured by the signature. Then the signature is verified and a Boolean value is given back. In this case, the signature is valid, so the next step can process. And the next step is the assertion evaluation, which is XPath-based addressing. And this addressing, first with /response, you can address the response element, then /assertion addresses the assertion, and finally /subject addresses the subject, and in this case, the user Bob gets authenticated as it is addressed as subject in this assertion. This is the normal processing of a service provider. So after this short introduction, I will come now to the attack and the prerequisites for the attack. So everybody who can gain one signed assertion can carry out or launch our attacks. So it is not important if what claims are in the assertion or if the assertion is already expired or attributes are in there which are not important. You only need one validly signed assertion from a trusted identity provider. And how do I get such an assertion? There are three ways. First is to simply register to such a service provider. For example, you could register to Google Apps, and then you can issue your assertions on your own, yourself. And the second way is eavesdropping, which means you could launch a cross-site scripting attack or a DNS spoofing attack. This is a little bit trickier, but also possible. And the third way, which is my favorite way, is to simply ask Google. Because if you search for an assertion, there are many posts in the internet from developers who have problems with the SAML protocol, and they posted their validly signed assertions. And you can get them for free from there. So the impact of our attack, as said before, is really devastating, because you could circumvent the whole protection XML signature gives to the assertion. So an attacker can modify the assertion with any arbitrary content, add or remove content, everything is possible. So let's start really simple with a signature exclusion attack. This attack authenticates the user Bob, and the attacker has gained this assertion. So first he simply removes the signature element and then modifies the assertion. In our case, the subject gets modified from Bob to admin. And this attack is really trivial, but we were really impressed that at least 3 of the tested service providers accepted such assertions. Okay, now let's come to the real attacks. So again, this message authenticates the user Bob, and what the attacker does is first it includes a wrapper element with a copy of the original assertion into the XML message. Then the attacker changes the ID attribute of the original assertion from 1 to 3 to an arbitrary value, in this case 666. And now the URI attribute points to the copied element, and finally, in the last step, the attacker modifies the original assertion, also here from the subject from Bob to admin. So, and now we come to the processing on the service provider side. And here in the first step, after sending the assertion to the malicious assertion to the service provider, the signature verification takes place, and because this is ID based, the verification runs through and is valid. But the assertion evaluation is XPath based, and so the evil content gets evaluated. Yes, that's true. It's really worked. So I have some other real-world examples because you have a vast amount of possible attack vectors. And the other example is for OIO, saml, which is a framework from the Dutch state for e-government purposes. And on this attack, the attacker simply copied the original assertion into the signature element, then changed the ID, and also changed the content of the original assertion. This also worked. And the second example is for WSO2, which is a SOA-based open source cloud platform. And here we have another form of XML signature because the whole response message is signed. And the attacker simply copied the whole response message into the original response and changed the ID attribute and the content of the original assertion. Okay. So after seeing this trivial attacks, one could assume is XML signature wrapping always that easy? And while we investigated several frameworks, we found OpenSaml, which is really popular and also applied in many famous SAML frameworks like Shibboleth or Swiss ID. And OpenSaml implements some countermeasures. First, XML signature validation, which means you cannot duplicate ID attributes into an XML document, and also the document must be XML schema conformed, which means that not any content is allowed in such a document like the wrapper element which we included for our attacks. And also OpenSaml checks that the assertion is signed by an enveloped signature, which means the signature must be directly in the assertion element. So on the right side you see the attack message for OpenSaml. And we will now run through each countermeasure and how we circumvented them with this attack message. So first, the schema validation. We put the copied assertion simply into the SAML extensions element, which is an element that allows any arbitrary value by default. It's so specified in the XML schema. And so, sorry, I forgot to say the basic attack is to use duplicate ID attributes. That's important. And this is the extensions element. And now we come to duplicate ID attributes. And normally this should throw an error message. But OpenSaml uses an XML parser library, which is Apache Xerxes, that had a bug. And this bug led to the case that this is true, or that this check failed by mischief. Because of this bug, and to our best knowledge, this bug is still open in Apache Xerxes. Okay, let's come to the enveloped signature. As you can see, the assertion, the signature is directly in the assertions element, so this is okay, this check. And also, OpenSaml checked if by string comparison, if the URI attribute here is the same than the ID attribute in the assertion, and this is also true with the, by a string comparison. So we run through all countermeasures OpenSaml implemented, and now the big question is which assertion gets validated by the signature verification. And on the left side, you see the evil response message for OpenSaml C++, for the OpenSaml C++ implementation. And here, the signature verification verifies the first found element in the signature. And therefore, the good assertion is before the evil one. And in the second case, we have the OpenSaml Java implementation. And interestingly, there, the last found assertion gets validated by the XML signature, and so therefore we just copied the good element after the evil element, and yeah, that's all. Okay, as you saw, there are many different attack vectors and permutations possible because of the flexibility of XML. And because making handcrafted XML messages is very boring and error prone, because you have to convert them into base 64 and back and forward. It's really boring and error prone. So we developed a penetration test library which creates about 1,500 attack messages out of one given assertion. And this penetration test library considers a vast amount of attack vectors, like the shown XML signature exclusion, or it simply signs an assertion with a self-signed untrusted key, and also considers or takes in place the XML schema validation and different ID processing types like same ID, different ID, or simply remove all IDs of the document. And also order and position of signature and assertion is taken into account. So let's come to the results of our practical evaluation. On the top you see the XML signature exclusion attacks. These attacks were possible for OpenFNs, Apache Access 2, and JOSSO2. All three failed in verifying the XML signature. And XML signature wrapping attacks were possible from 9 out of 14 tested frameworks. Like prominent examples, the IBM's DataPower XS40 XML security gateway. Okay, and we also found 2 implementations that did not reveal flaws in contrast to their common reputation. Yeah? The secure frameworks in this case are the .NET Windows-based Identity Foundation and we should say the really good simple saml PHP implementation, which is an open source project. Both were not susceptible to our attacks. Good. To sum up, we systematically tested 14 SAML frameworks, and we found out that 80% of them had critical signature wrapping flaws. And we also discovered a new sophisticated XML signature wrapping attack on the OpenSaml framework. And we closely collaborated with the security response teams of these projects to fix the flaws. And XML signature wrapping attacks are known since 2005, but they seem not to be in the focus of the research community and the developers today. And we think that there are many implementations out there which are susceptible to this kind of attacks. And let's come to the lessons learned. Always when you apply XML signature, think of XML signature wrapping attacks. And as future work, we want to integrate our test library penetration test library into the WS attacker framework to fully automate the penetration test for browser-based single sign-on penetration testing. Okay. Now I'm at the end of my talk, and I thank you for your attention, and don't hesitate to ask any questions. Thank you.
Andreas? Hey. Oh, wait. I have 2 microphones. Whoa. I'll behave. So given what you've shown us, do you think there's much value in continuing to sign XML?
Yeah. Okay, yeah, this is a good question because the attacks are really devastating. The problem is the XML signature standard is really complicated. There are many possible, you can have envelope signatures or enveloping signatures. It's really complicated, XML signature. And people who implement XML signature, the XML signature standard, don't understand everything. It's really complicated. That's the problem. But I think it's worth to sign with XML signature. So, other questions?
Do we have anything on IRC?
No.
Nope. Okay. Oh.
No.
Oh, wait,
Okay. What?
just came in.
Oh.
Isn't the spec broken if the ways using verification and extracting the subject are done using different technologies? And how to improve the implementations?
That's a good question. The standard isn't broken. That are implementation flaws. And how to improve is, I've prepared some slides for this. The general problem is that the processing modules have different views on the same document. And so to fix these flaws is to give the processing modules the same view on the document, which isn't always that easy, because if you think of SOA-based architectures with web services where different modules can be on different hosts, this could be really difficult. Yeah? And also if you use different underlying XML libraries, parsing libraries.
Any other questions? Okay, cool. So last couple things, on your way out, if you're not staying for the next talk, please go out the front door, not the back. Please take your trash with you or somebody else's trash. Just if you see any bottles, please take them. And give Andreas another huge round of applause, because that was awesome.